Hi everyone, welcome to Cola Teaches Math. So today we're going to talk about 8.11, finding the volume using the washer method. So you can see here I have one curve that I'm highlighting in blue, y equals x squared, and one curve I'm highlighting in that pretty mint green, x equals 2, and we're bound by the x-axis in pink. And I'm asking you to rotate the region R about the y-axis. Okay, so here needs to be your thought process, and right now I just highlighted in yellow. I'm going to flip it over the y-axis. We're not drawing it three-dimensional. This is how I teach it. And we're just essentially doing a line reflection. So right away you're thinking to yourself, okay, flipping over the y-axis means we're going to be integrating with respect to y. And whatever discs I draw need to be perpendicular to the y-axis. That's kind of like a key thing here. So you can see right now the empty space I'm highlighting in blue, and I want us to find the volume of the yellow region, and it's rotating to create a three-dimensional solid. So we're going to draw the big disc from one end to the other end, and you shade up until the axes you're flipping over. So the big disc is going to be right minus left, 2 minus 0. Now, the small is going to span the empty space. That's in pink right there, shade up until the y-axis. And here's the thing, because it's dy, we need to get the curve out of y equals and solve for x. You get plus or minus rad y, but that's just positive rad y because we're in the first quadrant. So the small radius is going to be rad y minus 0 or just rad y. All right, let's plug it in. Volume equals pi big radius squared minus small radius squared dy. And now our bounds need to be y values, so we can see that this curve is going to go from 0 to 4 because that is the y value that this curve is sandwiched in between. Excuse me. Okay. Now let's look at this next example down below. So we have the same curve, y equals x squared, but now I restricted it in a different way. So I have the line in blue, y equals 4, and the y-axis, and we're going to rotate this region R about the x-axis. Okay, so you can kind of visualize it as like one of those fancy coffee tables, half of it. That's how I think about it. My kids told me it's a fancy yo-yo, half of it, I don't know. Anyway, so we're rotating it about the x-axis. It's going to be dx. So the discs that I'm going to draw have to be perpendicular to the x-axis. So right away we're thinking to ourselves, okay, that integral cannot have any y's, it can only have x's. We are finding the volume of this yellow region. It's three-dimensional, and that is the empty space that I highlighted in that magenta. Okay, so now let's go ahead and find the big and small radius. So the big radius has got to span top to bottom, shade up until the x-axis. So it's going to be 4 minus 0. The big radius is just going to be 4. The small radius is going to span the empty space. So we're going to go ahead, draw that small radius in blue. The top function is x squared. The bottom function is 0, which is the x-axis. Once we know that, easy peasy. Let's plug it into the formula. Pi, the integral, big squared minus small squared dx. And now we need to use x values. And this curve is in between x equals 0 and x equals 2. And that's it. You can type it in your calculator, integrate it by hand.